In this video, I'm going to introduce the Pythagorean theorem and I'm going to prove it to you. So, let's start off with a square. All of its angles are right angles, and all of its sides are equal. So, I'm going to draw another square inside of it. And I'm going to label these sides. So I'm going to label this side A. These are triangles. You can see these are 4 triangles, a square and a bigger square. I'm going to label this side of this triangle A, this one A, this one A, and this one A. I made it to where these triangles are all equal. What I did was I made A equal to this length, and this length. And I made B equal to the side of the triangle, side of the square minus A. This is going to be B, B, B. Sorry, my finger was in the way. And this is all C, 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 C. I'm going to prove that this is a square. Let's see how I'm going to prove that this is a square. First of all, this angle plus this angle plus this angle equal 180. This angle is 90. This angle is 90. So let's call this angle X and this angle Y. So we have X plus Y plus 90 is equal to 180 degrees. Subtract 90 from both sides, we get that X plus Y is equal to 90. So X plus Y is equal to 90. This is X and this is Y. So X plus Y is 90 and this remainder is 90. So this is a right angle, this is a right angle, that's a right angle, and that's a right angle. And all these sides are equal, so this is a square on the inside. Now, C squared, if I wanted to get the area of the inner square, I'm going to call it C squared. That's just C times C is equal to the area of the larger square, which is A plus B squared, minus the area of these 4 triangles added together, which is going to be 4 times half times A times B. Now let's simplify. C squared is equal to A squared plus 2AB plus B squared. And this just goes to 2. Minus 2AB. And I just foiled this. This right here is just A plus B. Like that. It's just 2 binomials, A plus B. And this right here just cancels. 2AB and 2AB cancels. So C squared, the area of this square, is equal to A squared plus B squared. What does that mean? What does that mean? C squared is equal to A squared plus B squared. Let me erase all of this and show you what that means. So I'm gonna write that down back over here. A squared plus B squared is equal to C squared. So let's start with a right triangle. I'm gonna label this A, B, and C. So a right triangle, this side right here, the longest side is called the hypotenuse. It's always the opposite to right angle. So, what this is saying up here, a squared plus b squared equals c squared. If you was to get a and square it, get a times a. A times a is equal to a squared. And a squared is the area of this square right here, which has an a of this side, a of this side, a of this side, and a of this side. So the area of this square is a times a, which is a squared. So a squared plus b squared, because this right here, b times b, a squared plus b squared is equal to the area of this square. This is c, this is c, every side length of this is c, so c times c squared, c times c is c squared, and that's equal to a squared plus b squared. And this is useful with right triangles only. You can only do this with right triangles. They have something called the law of cosines that's used in trigonometry to get the Pythagorean theorem in terms of triangles that aren't right angled, but that's future reference I'm going to talk about. Now I'm talking about right angle triangles. You use the Pythagorean theorem only for right angle triangles. So, a squared plus b squared equals c squared. So I'm going to give you an example of this. So, here's a right angle triangle. I'm going to say this is 3, this is 4. So, what's the hypotenuse's length? The Pythagorean theorem is useful for solving the lengths of sides that are missing if you know two sides. That's the point of the Pythagorean theorem. If you got two side lengths known, you can solve for the third side. And actually, what I'm going to do is, I'm going to take that side away. I'm going to label this side 5. Okay? So the hypotenuse is 5, this leg is 3. So, you use the Pythagorean theorem. A is equal to 3, B is unknown, and C is equal to 5. So 3 squared, remember a squared plus b squared is equal to c squared. A squared, a is 3, a squared is just 3 squared, plus unknown squared is equal to 5 squared. So that's 9 plus b squared is equal to 25. Now we're going to subtract 9 from both sides, just rearranging the equation. B squared is equal to 16. And now we're going to square root to both sides. We're going to take the positive square root, because the side's a positive number. And B is equal to 4. Now this is something you should always remember. Anytime you have a triangle with the leg 3, 4, and it's a right triangle, the hypotenuse is always 5. They call it a 3, 4, 5 right triangle. It's called a Pythagorean triple. And they got other Pythagorean triples. There's a whole bunch of them. I think there's an infinite amount of them. But for now, we're just going to talk about 3, 4, 5. Always remember that if you have a right triangle, it's 3, 4, then this side is always 5. And that's the Pythagorean theorem. There's many proofs. I just gave you one proof. I might give another proof in the future. But for now, that's that. Let's move on.